Welcome to P.U.R.E 6. Today we will be seeing about the topic triangulation method for class 11. And today's topic is a good 3-mark question which is being given in the 5-mark section of the book back. So this method is nothing but it is used when to find larger distance. To find larger distance, this method is applied. For example, if we need to find the distance between Moon and Earth or any planet with respect to Earth, we will be using triangulation method. Of course, to measure the distance between Moon and Earth, we use radar method or a parallax method, or we can use this method. So now to derive the final expression for this method, I'm going to use a diagrammatic explanation, which is nothing but a triangle, right angle triangle ABC. AB is the height of the tree and BC is the distance between the base point of the tree or the point of observation or position of the observer. Point C is called as the point of observation or position of the observer. Now, from point C, you are viewing the peak or the top of the tree, which is nothing but point A. Now, while seeing the point A from C, you are viewing with an angle theta. This angle is called as angle of elevation. So now I know what is BC, what is AB, and what is this theta. So to find the height of this tree, I'm going to use trigonometric functions, which are nothing but all those 6 functions. That is sin theta, cos theta, tan theta, and the reciprocal of all these 3 functions, which is nothing but cosecant theta, secant theta, cot theta. So sin theta is nothing but opposite by hypotenuse. Cos theta is adjacent by hypotenuse. And tan theta is the division of sin theta by cos theta. So sin theta by cos theta will give you opposite by adjacent. And cosecant theta is the reciprocal of sin theta, which is nothing but hypotenuse by opposite. And secant theta is the reciprocal of cos theta, which is nothing but hypotenuse by adjacent. And cot theta is the reciprocal of tan theta, which is nothing but 1 by opposite by adjacent is adjacent by opposite. Now I have all these 3 functions. Now the question arises, which function do I need to use in order to find the height? If I use sin theta, am I going to get the height? No. Why? Because I know what is, now first you say what is adjacent, what is opposite, and what is hypotenuse here. Adjacent is nothing but where 2 angles on the side of the triangle which has 2 angles. It is nothing but this BC is the adjacent side. This AB is the opposite side which has only 1 angle, because that is 90 degree. And the side opposite to the 90 degree is called as hypotenuse. Now I don't have any data to substitute in the place of hypotenuse, right? I don't have any data, I don't have any variable or any value in the place of hypotenuse. So I cannot substitute in the place of hypotenuse any value. So by that way, sin theta becomes impossible. If I am going to use cos theta, in that also I have hypotenuse. There also I cannot substitute any value. So this also becomes impossible. So in the place of tan theta, I don't have any hypotenuse. I have only opposite or adjacent. I have both adjacent and opposite. So I have H as opposite and X as adjacent. So I can substitute here. So this is possible. I cannot substitute in the place of cosecant theta because there is a value called as hypotenuse. So I cannot substitute in the place of hypotenuse because I don't have any variable or any value. So this is impossible. In the place of secant theta is also impossible. But in the place of cot theta, we can substitute because there is no value called as hypotenuse where I can substitute a value to that. So I can only substitute adjacent and opposite, which I have. I can substitute adjacent and opposite here. So this is also possible. So what are the 2 functions that I can use to derive the height of the tree? One is tan theta, and another one is cot theta. So these are the 2 functions that I can use to derive the height of the tree. Now, how to derive using these 2 functions? I know tan theta is equal to opposite by adjacent. Now I will be showing you how to derive the height using both the functions, not only one function. So opposite by adjacent. Here I have H as the opposite, so I'm going to substitute in the place of opposite, I'm going to substitute H, and in the place of adjacent I'm going to substitute X. h by x is equal to tan theta. So in this function, in this expression, what do I need to find? I need to find h, because the main aim is to find the height of the tree, so which is h. So I need to find this h. In order to find this h, I'm going to bring it in the form of like this. H is equal to I'm going to take it to the left hand side, which is x into tan theta. Tan theta. So this is my final expression. Now, how do I bring the height, bring this expression from cot theta? I know cot theta as adjacent by opposite. Cot theta is equal to adjacent by opposite. What is my opposite? Opposite is nothing but h. Adjacent is nothing but x. So adjacent by opposite is nothing but x by h, which is cot theta. Cot theta can be written as cot theta is equal to 1 by tan theta, because reciprocal of tan theta is called as cot theta. So I can write in the place of cot theta as 1 by tan theta, and when I cross multiply both the denominators, I get h is equal to x into tan theta, which is nothing but the final expression that I got using tan theta. So by these two conclusions, I can say the final expression for triangulation method is nothing but h is equal to x into tan theta, or product of x and tan theta. So using these methods, there is a sum in the example 1.1, which we will be seeing in the next video. Thank you.